Welcome back to the deep dive. You know, where we take your sources and kind of dig out all those like hidden knowledge gems,
Right.
the stuff that makes you go like, huh, I never thought about it that way.
Exactly. It's all about those aha moments, turning information overload
Right.
into something you can actually use.
Yeah. And today we are tackling a topic that is, well, it's super timely
Mm-hmm.
and honestly a little mind-blowing. We're talking about how AI
Okay.
is being used to study and predict climate change.
It's like giving climate science a turbo boost.
Yeah. You sent us a ton of articles from like researchers at USC, Stanford,
Mm-hmm.
even some big tech companies like IBM and Microsoft.
Yeah, it's a really hot area of research right now. A
Yeah,
lot of really cool stuff happening.
it is. And one thing that I noticed kept popping up in a lot of these articles was this idea of using the past
Okay.
to understand the future. It reminded me of that Einstein quote. If you want to know the future, look at the past.
Oh, that's a great connection. And it's
Yeah.
exactly what paleoclimatologists do.
Right.
They study things like ice cores and tree rings, all those natural archives that
Right.
hold clues about past climates.
It's like a detective story, but for the planet.
Exactly. And now AI is giving them a whole new set of tools
Yep.
to analyze all those clues.
I saw an article about something called the Linked Earth Initiative.
Oh, yeah, linked Earth.
It's this collaboration between, I think it was USC's Information Sciences Institute
Right.
and climate experts.
Yeah, and what's fascinating about Linked Earth is how it all started.
Okay.
It was actually a chance meeting between a climate scientist, Julian Emile Gay, and an AI expert, Yolanda Gill, at an NSF workshop.
I love those origin stories.
Right.
So what problem were they trying to solve? Was it just that there's too much data for humans to handle?
Well, that's part of it, but the bigger issue was that all this climate data was scattered
Yeah.
across different research fields, and each field was using its own jargon and ways of describing things.
Oh, so it's like trying to read a book where every chapter is in a different language.
Yeah, a perfect analogy.
Okay. So how did they use AI to like bridge that communication gap?
Well, Gill's team at USC used something called ontologies. Think of them like dictionaries
Okay.
that create a common language for all those different data sets.
Oh, okay.
And then they also established these reporting standards so everyone was describing their data in a consistent way.
So it's kind of like a universal translator for climate science data.
That's a great way to put it. And now, with this standardized data, researchers can use AI to analyze huge amounts of information
Right.
and uncover hidden patterns
Yeah.
that would have been impossible for humans to spot on their own.
That's pretty incredible. But it's not just about understanding the past, right?
Hmm.
We also need to know what's coming next.
Absolutely.
And that's where these AI emulators come in, right?
Yeah, the emulator. They're like the weather forecasters of the AI world, except they're way faster, and they can handle mountains of data in the blink of an eye.
One of the articles mentioned the European Center for Medium Range Weather Forecasts, ECMWF.
Yeah, the ECMWF.
They're already using AI emulators for their weather predictions.
That's right. And it's not just theory. They're seeing real improvements in the speed and accuracy of their forecasts.
And there was that example with Google DeepMind's GraphCast AI model.
Oh, yeah, GraphCast.
It predicted Hurricane Lee's landfall 9 days in advance.
Right, 9 days. And, traditional models were only giving us like 3 days notice.
Yeah. What was it about GraphCast that allowed it to do that?
Well, GraphCast uses a graph neural network.
Okay.
And this type of AI is really good at understanding those complex systems
Right.
with lots of interconnected parts, like the weather. It can spot those subtle patterns and connections that traditional models just miss.
So these emulators are helping us get a clearer picture of the future, but they're just a stepping stone to something even more powerful, right?
Yeah.
The Weather and Climate Foundation models.
You got it. Foundation models. Think of them as like the next generation of
Right.
AI emulators. They're trained on a much broader range of data. It's not just historical weather patterns. We're talking ocean currents, atmospheric chemistry, even human activities.
It's like they're supercharged emulators. They have a much deeper understanding of the Earth's systems.
Exactly. And because of that broader understanding, they can be used for a whole bunch of things, from forecasting weather
Right.
to predicting the spread of air pollution, even helping us understand how climate change will impact different regions and ecosystems.
This is starting to sound like science fiction, but it's really happening now.
It really is. And while there are still challenges, the potential is huge.
Mm-hmm.
They could revolutionize how we study and address climate change.
One article caught my eye. It talked about that famous hockey stick graph.
Oh yeah, the hockey stick.
The one that shows global temperatures going way up in recent time.
Yeah, it's a powerful visualization of how human activities are impacting the planet.
And apparently, updating that graph used to take months and months.
Right, a very manual, time-consuming process.
But now AI is changing that.
Absolutely. AI can sift through massive amounts of data,
Right.
from temperature readings to ice cores, and pull it all together much faster and more efficiently.
So we could actually get a real-time picture of how our planet's temperature is changing.
That's the idea. And AI can also help us predict when we might cross those critical climate thresholds
Oh, okay.
that scientists have been warning us about.
You mean like the 1.5 degrees Celsius target set by the Paris Agreement?
Yes, exactly. One of the articles highlighted research from Stanford where they used an AI model to predict when we might exceed that crucial threshold. And their findings were kind of a wake-up call.
What did they find?
Their AI model predicted that we're likely to hit 1.5 degrees Celsius above pre-industrial levels in the early 2030s.
Wow.
And what's even more concerning is that this prediction held true even if we make significant cuts to emissions in the coming years.
So even if we slam the brakes on emissions right now, we're still on track to exceed that critical threshold.
That's what the model suggests. It really highlights the urgency of not just reducing emissions, but also adapting to the changes that are already happening.
It's a stark reminder that climate change is not some far-off threat. It's happening right now, and we need to act fast.
Absolutely. And AI is giving us the tools to understand the problem and develop solutions in ways that we just never thought possible before. But we need to use these tools wisely and ethically.
That's a great point, and it leads us perfectly to the next part of our discussion, where we'll delve into some of the specific ways AI is being used to tackle those climate challenges. Stay tuned.
Welcome back to the Deep Dive.
Back for more.
Sure.
Last time, we talked about how AI is being used to understand past climates and even predict future warming trends using these AI emulators and foundation models.
Yeah, some pretty mind-blowing stuff. And we even touched on some of the implications with the hockey stick graph and potential warming scenarios.
Right.
It's a lot to take in.
It is. So for this part, maybe we can zoom in on a few specific areas where AI is making a real difference, like some concrete examples.
Sounds good to me. Where do you want to start?
Well, I'm thinking about extreme weather events.
Ah, yes, that's a big one.
Yeah.
And it has huge implications for disaster preparedness. Even a few days heads up can make a world of difference.
Yeah, totally. We're talking about things like hurricanes, floods, wildfires, right?
Exactly. All those events that are becoming more frequent and intense because of climate change.
Right. And traditional models have made progress. But is it fair to say that AI is pushing the boundaries even further?
Oh, absolutely. Remember we talked about Google DeepMind's GraphCast?
Yeah.
Predicting Hurricane Lee's path 9 days in advance.
That was incredible. Can you remind me how they were able to do that?
Well, one of the key things is that AI can process massive amounts of data, including real-time observations from satellites and weather stations.
Right.
And then it can find those subtle patterns and connections that conventional methods might miss.
So it's like having a superpowered weather detective.
That's a great analogy. And it's not just hurricanes. AI is being applied to predict all sorts of extreme weather, from heat waves and droughts to even flash floods.
So instead of just getting a general warning about a region, AI could actually pinpoint the specific neighborhoods or streets that are most at risk.
That's the exciting part. We can achieve a level of accuracy and detail that was never possible before.
And that level of precision could actually be life-saving.
Absolutely.
You could deploy emergency resources with pinpoint accuracy, get help to the people who need it most.
It's a game changer for disaster response. No doubt about it.
Okay, so we've talked about extreme weather, but what about the longer-term impacts of climate change? How is AI helping us manage resources in a world that's, getting warmer and more unpredictable?
That's a great question. AI is being used in many different ways, from tracking deforestation and monitoring water quality to even managing agricultural land more efficiently.
Can you give me some specific examples?
Sure. So, there are AI systems now that are being used to monitor forests for illegal logging activity.
Oh, wow.
They use satellite imagery to identify areas where trees are being cut down, often almost as it's happening.
It's like having an AI watchdog for the rainforests.
Exactly. And these systems are getting more sophisticated all the time.
Okay.
They can now even identify the types of trees being cut down and estimate the amount of carbon being released into the atmosphere.
So we're not just detecting deforestation, we're also measuring its impact on the climate.
Precisely. And this data is crucial for holding polluters accountable
Right.
and for understanding the true cost of deforestation.
So it's not just about monitoring, right? AI can also help us make better decisions about how to manage our resources in a sustainable way.
Absolutely. Take agriculture, for example. AI is being used to optimize irrigation systems, predict crop yields,
Okay.
and even help farmers adapt to those changing climate conditions.
So it's like having an AI-powered farming assistant.
Exactly. These systems can analyze data about soil conditions, weather patterns, even market trends
Wow.
to help farmers make the best decisions for their crops and their livelihood.
It seems like that's especially important as climate change continues to have a bigger and bigger impact on agriculture.
You're absolutely right. These types of tools will be essential for ensuring food security in a changing world.
So we've covered predicting extreme weather, managing resources.
Mhm.
What other areas of climate science
Mhm.
are being revolutionized by AI?
Well, one that often gets overlooked is the impact of climate change on human health.
Oh, that's a good point. We often think about the environmental consequences,
Mm.
but climate change is also a public health crisis.
Exactly. Rising temperatures, extreme weather, changes in disease patterns, all of these can have serious consequences for human health.
And AI can help us understand these connections and prepare for these health challenges.
That's the idea. For instance, AI models are being used to predict outbreaks of diseases like dengue fever,
Okay.
which are very sensitive to changes in temperature and rainfall.
So we're using AI to track disease outbreaks before they even happen.
That's the goal. By analyzing things like weather data, mosquito populations, and human travel patterns,
Right.
AI can identify those areas at high risk for dengue outbreaks, allowing public health officials to take preventative measures.
Wow, that could potentially save so many lives.
It really could. And it's not just infectious diseases. AI is also being used to study the long-term health impacts
Okay.
of climate change. Things like respiratory problems from air pollution and mental health issues related to, say, displacement and trauma from extreme weather events.
It's a really complex and evolving field, but it sounds like AI is giving us the tools to at least better understand those health risks.
It is. And with that understanding, we can develop strategies to protect the most vulnerable populations and build more resilient healthcare systems.
Okay, so we've talked about AI's role in predicting extreme weather, managing resources, safeguarding human health.
Mm-hmm.
What about understanding the bigger picture? How is AI being used to improve climate modeling and prediction?
Oh, that's a crucial area where AI is making a big impact.
Okay.
Traditional climate models, the ones that try to simulate the entire Earth system,
Right.
are incredibly complex and require massive computing power.
But even with the most powerful supercomputers, those models can be limited in their resolution and accuracy.
That's right. And that's where AI steps in. AI algorithms can help speed up those complex simulations, allowing scientists to run more models at higher resolutions
Oh.
and explore a wider range of climate scenarios.
So it's not about replacing those traditional models, but rather enhancing them.
Exactly. AI can also help improve the accuracy of these models by identifying and correcting biases, filling in gaps in data, and even discovering new relationships between different climate variables.
This sounds like a huge step forward in our ability to actually predict future climate change.
It is. The more accurate our models are, the better we can understand the potential impacts of climate change.
And with a better understanding of the risks, we can then develop more effective strategies for mitigation and adaptation.
Precisely. It's a continuous process of refinement, and AI is playing a crucial role in accelerating that process.
So as we gather more data about the Earth system, AI is only going to become even more important for climate modeling.
Absolutely. It's an exciting time to be working in this field. There's so much potential.
Welcome back to the Deep Dive. We've spent the last 2 parts exploring all the exciting ways AI is being used to tackle climate change.
From, deciphering ancient climate clues
Right.
to predicting future warming trends and even managing resources more efficiently. It seems like AI is really becoming an invaluable tool.
Yeah, but like with any powerful technology, it's important to consider, the potential pitfalls
Right.
to make sure we're using it responsibly.
Absolutely, especially when it comes to something as complex and critical as climate change.
Yeah. So for this final part, maybe we can shift gears a little bit
Okay.
and talk about some of the challenges and limitations of using AI in climate science.
Sounds good. What are you thinking about?
Well, one thing that comes to mind is, we've talked a lot about these AI models being trained on all this historical data.
Right.
But what happens when the climate change is coy in ways that we haven't seen before?
That's a great question, and it's one of the biggest challenges in climate science.
Okay.
The climate's a complex system, and it's always evolving. What might have been true in the past may not hold true in the future.
So these AI models could actually become less accurate over time as the climate continues to change.
It's definitely a possibility. That's why it's so important to keep updating these models
Right.
with new data and to be aware of their limitations.
So it's not just a set it and forget it kind of thing.
Yeah.
You constantly have to be monitoring them, refining them.
Exactly. It's an ongoing process.
Okay.
And it's not just about the data either. We also need to be really mindful of the assumptions
Right.
that are baked into these AI models.
Can you give me an example?
Sure. Let's say we're using an AI model to predict the impact of sea level rise on a coastal community.
Okay.
That model might make certain assumptions about, population density, infrastructure, even economic development.
And if those assumptions are wrong, the predictions could be way off.
Exactly. And that could have real-world consequences, It could lead to misallocation of resources or even put people's lives at risk.
So how do we make sure that these AI models are as reliable and accurate as possible?
Well, it starts with transparency.
Okay.
We need to be very clear about the assumptions that are being made and the data that's being used.
So it's not just about the results, it's about understanding how those results were reached.
Right. And this transparency is also crucial for building trust.
If people don't understand how these AI models work, they're not going to trust the predictions.
And trust is essential if we want to use AI to, inform policy decisions or guide climate action.
Absolutely. We also need to make sure that these AI models are being developed and used ethically.
What does that look like in practice?
Well, for one thing, we need to make sure that the data being used is representative and unbiased.
Okay.
We don't want to perpetuate existing inequalities or discriminate against certain groups.
Right. So, if we're using AI to predict climate migration patterns,
Right.
we need to be careful that the data that just reinforce existing biases.
Exactly. And we also need to be mindful of who benefits from these AI technologies.
That's a good point. We don't want to create a situation where the most vulnerable communities are the ones who are left behind.
That's a crucial point. AI has the potential to be a powerful tool for climate justice, but only if it's developed and used in a way that benefits everyone.
So it's not just about the technology itself, it's about how that technology is applied in the real world. Absolutely. It's about using AI to create a more sustainable and equitable future for all.
Well, that brings us to the end of our deep dive into AI and climate science.
It's been a fascinating conversation.
Yeah, we covered a lot of ground, from those really exciting possibilities to, some of the potential pitfalls.
And hopefully we've given our listeners a better understanding of this really complex and rapidly evolving field.
If you found this deep dive helpful, be sure to subscribe to the deep dive for more insightful explorations of the topics that matter most to you.
And don't forget to check out our playlist for other episodes that might pique your interest. We cover a wide range of subjects, so there's bound to be something for everyone.
Thanks for joining us on this deep dive. Until next time.